Right now, every galaxy in the universe is racing away from us at speeds that would make your head spin. The farther away they are, the faster they flee, some moving at over 600,000 miles per hour. But here's where it gets weird. They're not actually moving through space at all. Space itself is stretching, carrying everything with it like dots on an inflating balloon. We'll journey through the discovery that shattered our understanding of reality. Explore why asking what the universe expands into makes no sense, and discover how space itself can grow without needing anywhere to grow into. We'll visit the cosmic microwave background, witness dark energy tearing the fabric of existence apart, and confront the possibility that our universe has no edge, no outside, and no end. Don't forget to like and subscribe for more mind-bending cosmic journeys. Prepare yourselves. We begin. Music. In 1929, a quiet astronomer named Edwin Hubble pointed his telescope at distant galaxies and discovered something that would shatter our understanding of reality forever. Hubble noticed that nearly every galaxy he observed was moving away from us. But this wasn't random movement. The pattern was perfect, almost mathematical in its precision. Galaxies twice as far away were moving twice as fast. Galaxies 3 times farther were racing away 3 times faster. It was as if the entire universe was participating in some cosmic choreography we had never noticed before. Think of it like standing in the middle of a crowd where everyone starts walking away from you at the same time. Except in this cosmic crowd, the people farther from you aren't just walking, they're sprinting. And the people at the very edges are running so fast, they're practically flying. Hubble measured this using something called redshift. When light travels from a moving source, it stretches or compresses like sound from a passing ambulance. Light from galaxies moving away from us gets stretched into longer, redder wavelengths. The faster they move, the redder they appear. Some galaxies were so redshifted that their light had been stretched to nearly twice its original wavelength. This discovery revealed that space itself was growing. Every cubic inch of empty space was slowly expanding, pushing galaxies apart like raisins in rising bread dough. The universe wasn't static and eternal, as everyone had believed. It was dynamic, growing, evolving with each passing second. But Hubble's discovery raised a question that would haunt physicists for decades. If the universe is expanding, what is it expanding into? The answer would challenge everything we thought we knew about space, time, and reality itself. What we discovered next would make Hubble's revelation seem simple by comparison. The word expanding tricks our brains into imagining the universe like a balloon growing bigger inside a room. This comparison feels natural because every expansion we experience in daily life happens within something larger. A balloon expands into the air around it. A city expands into the surrounding countryside. Even an explosion expands into the space that was already there. Our minds automatically search for the room that contains our expanding universe. But cosmic expansion works completely differently. The universe isn't growing into pre-existing space because there is no pre-existing space. Space itself is what's expanding. It's like imagining a balloon that creates new room around itself as it inflates without any walls or boundaries to push against. Picture a piece of graph paper with dots marked on it. Now imagine the paper itself stretching so that every square becomes larger. The dots move apart, but they're not traveling across the paper. The paper is carrying them apart by growing beneath them. This is closer to what happens in our expanding universe. The stretching happens everywhere at once. Between Earth and the Moon, space expands by about 1 1/2 in every year. Between our solar system and the nearest star, space grows by thousands of miles annually. Between distant galaxies, space expands fast enough to carry them apart at incredible speeds. Here's the mind-bending part. This expansion has no center and no edge. Every point in space sees every other point moving away from it. An alien on a galaxy billions of light years away would see us racing away from them at the same speed. We see them racing away from us. The expansion looks identical from every vantage point in the universe. Scientists call this the cosmological principle. No matter where you are in the universe, the view looks roughly the same. You're not at the center of expansion because there is no center. You're not near the edge because there is no edge. But if space itself is expanding and there's no edge or center, then what lies beyond the boundaries of everything we can see? The balloon analogy that everyone uses to explain cosmic expansion actually makes the mystery worse, not better. When teachers inflate a balloon to show how galaxies move apart, they're accidentally reinforcing the wrong idea. Students see the balloon expanding into the classroom air and think, aha, so the universe must be expanding into some kind of cosmic air too. But this misses the most important point. The balloon example only works if you ignore everything outside the balloon's surface. Imagine you're an ant living on that balloon. Your entire world is the rubber surface. You can move north, south, east, or west across the surface, but you can't move up or down into the air around the balloon. Those directions simply don't exist in your two-dimensional world. As the balloon inflates, your world gets bigger, but there's no outside for you to worry about. Now, take this idea and add one more dimension. We live in a three-dimensional space that might be expanding just like the ant's two-dimensional surface. Just as the ant can't step off the balloon into the surrounding air, we can't step out of our three-dimensional universe into some fourth spatial dimension. The key insight is that expansion doesn't require an outside. The balloon's surface can grow without needing to expand into anything from the ant's perspective. The surface simply contains more area than it did before. Similarly, our universe can contain more space than it did before without requiring anywhere for that space to come from. This creates a profound shift in thinking. Instead of asking, what is the universe expanding into, we should ask, how is space itself changing? The universe isn't moving through some larger container. It is the container, and the container is growing. But this raises an even deeper question. If space itself is expanding, what does that mean for the nature of space and time? Space is an empty nothingness waiting to be filled. It's a physical thing with properties, and those properties are changing. Most people think of space as the stage where physics happens. Planets orbit, light travels, and forces act across this invisible backdrop we call space. But Einstein showed us that space is more like an actor in the cosmic drama. It bends around massive objects. It vibrates when disturbed, and yes, it expands as time passes. Think of space like a fabric that can stretch. When you pull out a piece of elastic, you're not adding new material. You're spreading the existing material over a larger area. The fabric becomes thinner and less dense, but it covers more territory. Space expansion works similarly, except instead of becoming thinner, space maintains its properties while simply providing more room. Here's where it gets strange. New space is constantly being created. Every second, about 1 cubic foot of new space appears between Earth and the Moon. Every year, roughly 15 billion cubic miles of new space materializes between our galaxy and the next closest galaxy. This isn't empty space moving in from somewhere else. It's genuinely new space coming into existence. This creation happens at a rate that depends on distance. Close objects barely notice the expansion because gravity and other forces easily overcome it. Your body isn't expanding. Your house isn't expanding. Even Earth's orbit isn't expanding. But at cosmic scales, where distances are measured in millions of light years, expansion becomes the dominant force. The expansion rate tells us something remarkable. Space is being created at about 70 kilometers per megapar. That means for every 3.4 million light years of distance, space expands fast enough to carry objects apart at 70 kilometers double the distance, double the speed. But if space is a physical thing that can expand, then what exactly is doing the expanding? The afterglow of creation itself still fills every corner of the universe, and it's getting stretched by expansion right now. About 380,000 years after the Big Bang, the universe cooled enough for the first atoms to form. Before this moment, space was filled with a hot glowing plasma that blocked light from traveling very far. But when atoms finally formed, light could suddenly travel freely across the entire universe. This first light, the cosmic microwave background, is still traveling through space today. Imagine a camera flash going off in a room filled with thick fog. The light scatters and bounces around, unable to reach your eyes clearly. But if the fog suddenly clears, you'd see that flash illuminating everything at once. The cosmic microwave background is like that clearing moment, frozen in time and stretched by billions of years of expansion. When this ancient light first started traveling, it was hot and bright, glowing at about 3,000 degrees. But as space expanded, the light waves got stretched along with it. Light that started out as visible orange and red got stretched into infrared, then into microwaves, then into radio waves. Today, that same light has a temperature of just 2 7/10 degrees above absolute zero. We can detect this ancient light coming from every direction in the sky. It's remarkably uniform, varying by only about 1 part in 100,000 from one direction to another. This uniformity tells us that the early universe was incredibly smooth and that expansion has been happening in all directions equally. The cosmic microwave background gives us a baby picture of the universe when it was only 380,000 years old. But more importantly, it shows us expansion in action. Every microwave photon we detect today was once a much shorter wavelength that got stretched by 13.8 billion years of cosmic expansion. But measuring this ancient light revealed something nobody expected about how fast expansion is happening. The universe is expanding at different rates depending on where you look. And this contradiction is driving physicists to the edge of madness. When we measure the expansion rate using nearby galaxies, we get one answer. When we measure it using the cosmic microwave background, we get a different answer. These two measurements should match perfectly, but they don't. It's like using two different rulers to measure the same table and getting different lengths. Using nearby galaxies, astronomers measure the expansion rate at about 73 kilometers per megapar. This means that for every 3.4 million light-years of distance, space expands fast enough to carry objects apart at 73 kilometers/s. But using the cosmic microwave background, physicists calculate the expansion rate at about 67 kilometers per megasecond. 6 kilometers might not sound like much, but in cosmology, this difference is huge. It's like discovering that your car's speedometer and GPS disagree about how fast you're traveling. Either one of your instruments is broken or something fundamental about the road itself is changing. This discrepancy has a name: the Hubble tension. It suggests that either our understanding of the early universe is wrong, our measurements of nearby galaxies are wrong, or something about the expansion process itself has changed over time. Some physicists think dark energy is evolving. Others believe there are unknown particles or forces affecting expansion. The tension gets worse as measurements become more precise. Instead of converging on a single answer, the two methods are becoming more confident in their different results. It's as if the universe is telling us two different stories about its own expansion, and we can't figure out which one is true. This mystery points to something profound. The expansion of space might not be as simple as we thought. Every search for the edge of the universe leads to the same maddening conclusion. There isn't one. Humans are wired to think in terms of boundaries. Every room has walls. Every country has borders. Every lake has shores. We instinctively assume that the universe must have an edge somewhere, a cosmic boundary where space simply stops and something else begins. But decades of searching have revealed that this edge doesn't exist. Consider what an edge would actually look like. Imagine traveling in a straight line through space for billions of years, passing countless galaxies and stars. Eventually, you'd expect to reach a place where galaxies become scarce, then rare, then disappear entirely. Beyond that, you'd find empty space. And beyond that, what? A wall. A void, a sign that says universe ends here. The problem is that observations show the universe looks roughly the same in every direction, no matter how far we look. Galaxies are distributed evenly across space out to the very limits of our vision.